Hello friends, in this AV we are going to do the numericals of the second chapter of class 10 ICSE physics, that is work, energy and power. We are going to talk about the third exercise, that is exercise 2C, numericals in this AV. So exercise 2C, the first numerical says a ball of mass 0.20 kg is thrown vertically upwards with an initial velocity of 20 meter per second. So we have been given the mass and we have been provided with the velocity. We have to calculate the maximum potential energy it gains as it goes up. So here you can see we have written the given things, that mass is given as 0.20 kg, initial velocity is 20 meter per second, and we know that the potential energy at the maximum height is equal to initial kinetic energy. Now when you throw anything up, please remember that the total energy is nothing but the sum of the kinetic and potential energy. So when we are talking about the potential energy at the maximum height, that will be equal to the initial kinetic energy, because the sum of the energy, that is the total mechanical energy, that is sum of the potential and kinetic energy, cannot be different. It will be same at all points. So here initial kinetic energy can be calculated using the mass and the velocity which has been provided to us. So we use the formula for kinetic energy, that is half mv square. We put the values. After substituting the values, that is mass is 0.20 kg and velocity square is 20 multiplied by 20. We do the calculation and the answer comes out to be 40 joules. Now let's look at the second question. It says a stone of mass 500 gram is thrown vertically upwards. Now here the mass has been given to us in grams, not in kg, so we need to convert it into kg, with a velocity of 15 meter per second. So we have been given the mass and the velocity. We have to calculate the potential energy at the greatest height, and the next one is the kinetic energy on reaching the ground, and the total energy at its halfway point. So here we are going to get all the answers as same, because as I told you, the sum of kinetic and potential energy is the total energy or the mechanical energy of the body. So please see, we have written potential energy at the greatest height is equal to initial kinetic energy. I've already explained this to you in the previous solution when we were talking about question number 1. So that is equal to half m, mass is 0.50 kg gram. So when we convert it to kg, we divide it by 1000, so we get 0.500 multiplied by velocity square, that is velocity is given as 15 meter per second, so that is 15 multiplied by 15. After calculation it comes to 56.25 joules. Now the second part of the question, to calculate the kinetic energy on reaching the ground, again that will be equal to the potential energy at the greatest height, because here we have said that the potential energy at the greatest height is equal to initial kinetic energy. So this we have already calculated, potential energy at the greatest height, that is 56.25 joules. So this will be the answer here again. Now the total energy at its halfway, the total energy is the sum of kinetic energy and potential energy. So at halfway it's going to be half sum of the kinetic energy plus the potential energy. So again this is going to be 56.25 joules. Now let's look at the third question. It says a metal ball of mass 2 kg is allowed to fall freely from rest from a height of 5 meter above the ground. We have to take the acceleration due to gravity as 10 meter per second square, and we have to calculate the potential energy possessed by the ball when it is initially at rest, the kinetic energy, of the ball just before it hits the ground, and what happens to the mechanical energy after the ball hits the ground and comes to rest. Now for the first part of the question, the potential energy possessed by the ball when it is initially at rest. When it is initially at rest, the height will be taken as 5 meter only. Okay, we assume that it is placed at 5 meters above the ground, and from there we release it. So for potential energy, the height will be taken as 5 meter. You may see here, so we have written potential energy of the ball is given as mgh. M is the mass, that is 2, acceleration due to gravity is 10, and height is 5. So we multiply it and we get the answer. The second part of the question asks us to find the kinetic energy of the ball just before hitting the ground. Now kinetic energy of the ball just before hitting the ground is nothing but initial potential energy. So that is again mgh. We have the mass, we have the acceleration due to gravity, and we have the height. So when we multiply it, we get the final answer for the kinetic energy of the ball just before hitting the ground. And for the third part of the question, what happens to the mechanical energy after the ball hits the ground and comes to rest? Now they have already given you the answer here itself. That is, the mechanical energy will be converted into heat energy and sound energy when the body comes to rest. So we go to the next question. Next is question number 4. It says, the diagram given below shows a ski jump. A skier weighing 60 kgf stands at A at the top of ski jump. He moves from A and takes off for his jump at B. He moves from A and takes off for his jump at B. Now B is at 15 meters and A is at the height 75 meters. Now calculate the change in the gravitational potential energy of the skier between A and B. Now here, to calculate the potential energy, we just have to use the formula of potential energy, the initial height minus the final height. So mg h1 minus mg h2, or you can take mg common and it will be mg h1 minus h2. And the second part of the question says, if 75% of the energy in part becomes kinetic energy at B, we have to calculate at which the skier arrives, calculate the speed at which the skier arrives at B, and we have been provided with the acceleration due to gravity. So we have to calculate the potential energy here in the first part, and the second part we have to calculate the velocity. So here we have written the first part of the question, that is, mass of the skier is 60 kg. The loss in potential energy is given as mg h1 minus h2. We have the value of mass, that is 60. We have the value of acceleration due to gravity. H1 is 75 meter as I had shown it to you from the figure, and H2 is 15 meters. So 60 into 10, 75 minus 10 is 60. We multiply it. So 6 into 6 is 36, and then we have 3 zeros. So we are writing it as 10 raised to the power 3. Now if we introduce a point in between, that means we are dividing by 10. If we are dividing by 10, we have to multiply as well. So if I multiply, the power 3 becomes power 4, and that divide by 10 makes it 3.6. So 3.6 into 10 raised to the power 4 joules. Now the second part of the question asks us to find the kinetic energy at B, which is 75% of the potential energy. So 75% of this figure, 75% of 3.6 into 10 raised to the power 4. So please do the calculation. It comes out to be 27,000 joules. Again 3 zeros, and if I introduce a point, it becomes 2.7 multiplied by 10 raised to the power 4 joules. So I write it as 2.7 into 10 raised to the power 4 joules. Now kinetic energy is given as half mv square. We have the value of kinetic energy, we have the value of mass, we need to calculate the velocity. So I put the value here. Kinetic energy is 27,000 is equal to 1 by 2 multiplied by mass is 60 into velocity we have to find out. So velocity square. So velocity square, if we keep on the left hand side and rest we write on the right hand side, then 60 divided by 2 makes it 30. 30 going to the other side becomes 27,000 divided by 30, which comes to be 900. And this is the value of square of velocity. So if we want velocity, we have to take the square root of 900, that is plus minus 30, and we take the positive value, and velocity is 30 meter per second. Now we look at the next question, that is question number 5. It says a hydroelectric power station takes its water from a lake whose water level is at the height of 50 meter. So this is my H1 above the turbine. Assuming the overall efficiency of 40%, calculate the mass of the water which must flow through the turbine each second to produce power output of 1 megawatt. That we have to take the value of acceleration due to gravity as 10 meter per second square. So height is 50 meter and the efficiency is 40%. So here the potential energy, we know that it's given as mgh, that is mass multiplied by acceleration due to gravity multiplied by the height. So useful work done is 40% of the potential energy. 40% of potential energy means 40% of mgh. So 40 divided by 100 makes it 0.4 multiplied by m, because we have to calculate the mass. We do not know the mass, which we will be calculating, multiplied by acceleration due to gravity, that is 10, multiplied by the height, which is 50 meter. So this comes out to be 200 m. M is the unknown quantity that we have to find out. Now we know that power is equal to work done per unit time. So power is 1 megawatt, which is equal to 1 multiplied by 10 raised to the power 6 watt. That is equal to 200 times multiply the, we have calculated it here, 200 m. So 200 multiplied by mass of water flowing each second. So 1 megawatt, we have written it in terms of watt, and it is 1.1 multiplied by 10 raised to the power 6 watt. That is equal to 200 multiplied by mass of water flowing each second. So from this, mass of water flowing each second is equal to 1 multiplied by 10 raised to the power 6 divided by 200. So 1 multiplied by 10 raised to the power 6 means 1 with 6 zeros divided by 200. So these two zeros will cancel out these two zeros. We are left with 10,000 divided by 2. It becomes 5,000 kg. That is the answer. Now let's look at the last question, which says the bob of a simple pendulum is imparted a velocity of 5 meter per second. We have been provided the velocity value when it is at its mean position. Now to what maximum vertical height will it rise on reaching the extreme position if 60% of its energy is lost in overcoming the friction of air? So 60% is lost, that means we have only the 40% energy of the initial kinetic energy of the resting position, which will be the potential energy at the extreme position. So here we have written that the potential energy at the extreme position is equal to 40% of the kinetic energy at the initial position or the resting position, because 60% is lost due to the air friction. So potential energy is given as mgh, that is equal to 40% of kinetic energy is given as half mv square. So here m and m can cancel out. So here after m and m will cancel out, and 0.4 divided by 2 becomes 0.2. Velocity is 5 meter per second, so velocity square is 5 square. That is equal to g is 10, acceleration due to gravity, multiplied by the height, which needs to be calculated. So height will be this divided by 10. So 0.2 multiplied by 25 divided by 10. This comes as 5 divided by 10, that is 0.5 meter. So that's all we have in this AV for you. Happy learning to you all. God bless.